Alright, so we're going to look at the Cartesian coordinate system, or also called the rectangular coordinate system. This is the standard XY axis you'll see in most algebra courses that you'll take. We describe locations here, we also call them points, or ordered pairs, by where they are with respect to the x-axis and where they are with respect to the y-axis. So we talk about their x-coordinate and their y-coordinate. Another two words you could use instead of x-coordinate and y-coordinate are abscissa and ordinate, though most people don't use those terms. Notice it's alphabetical though, x, y, a, o. So let's say I wanted to describe this location. I would notice it's 3 units to the right. It corresponds with 3 on the x-axis, and it also corresponds with 5 on the y-axis. So this has coordinates 3, 5. If I want to describe this point, I would notice this corresponds with -5 on the x-axis and +2 on the y-axis. So this has coordinates -5, 2. The place where you usually count from is from the center, and this has coordinates 0, 0, and it has a special name. We call it the origin. So we would say 3, 5 is 3 units to the right of the origin and up 5 units from the origin. These grid lines, x-axis and y-axis, divide the plane into 4 sections, which we call quadrants. So this first quadrant up in the upper right-hand corner, quadrant 1, has every point in there positive x and a positive y. And then we work counterclockwise. So we say the upper left is called quadrant 2, -x, positive y. And then we move down below that, that's quadrant 3, -x and -y. And then finally bottom right hand corner is quadrant 4, positive x, -y. So that's the basic setup of those. Alright, let's look at types of problems we may encounter. So this is asking us to plot these 4 points and describe which quadrant they lie in. So 2, -3 is 2 in the positive x direction and down 3. That would be over here. That would be point A, and that is quadrant 4. -1, 2.5. Notice you don't necessarily have to, these coordinates don't have to be whole numbers or integers. They can be fractional values. So -1, 2.5 is 1 left from the origin, and then positive 2.5 up. And that puts us there. That's point B, and that would be quadrant 2. -3, -4 is 3 lines to the left from the origin and 4 lines down. That would be put us in quadrant 3. And then 0, 5, that's starting from the origin. Don't go left or right, but go up 5, and that would be point D, and that is in quadrant, well, it's not in a quadrant, it's actually on the y-axis. Points on the axes are not in quadrants. Notice the x value is not positive or negative. 0 is a neutral number. Alright, this is another type of problem. They may give us some points and they ask us to identify the coordinates. So A, notice A is 1, 2, 3, 4 spots to the left from the origin, but not up or down. So -4, 0. B is 1, 2, 3, 4 to the right, and 1, 2, 3, 4 up. So its coordinates are 4, 4. C is not left or right at all. So 0 in the x direction, but down 4. So 0, -4. And D, notice that's kind of halfway between 2 lines over and 3 lines over, so probably -2.5, and up 1, 2, 3, 4, so -2.5, 4. And, just use your best judgment if it doesn't look like it lines perfectly up on a spot. Alright, so another thing we're going to look at is scatter diagrams. These represent relationships between ordered pairs of data. A lot of times you use these in like a statistical analysis to see if you think there's any kind of relationship between these two variables. So I'm going to look at a couple of examples. So, the table here shows the number of shots on goal and the number of goals scored for each of the 16 teams that played for a spot in the quarterfinal round of the 2010 World Cup soccer tournament. And so they asked us to graph a scatter diagram. Now, before you draw your grid for this, a lot of times you want to look and see what's the lowest value, the highest value your x's are going to have to go, and what's the lowest and highest your y's are going to have to go. So looking here, looks like for x, the lowest is 2, and we could go up to all the way up to 9, so maybe 1 to 10 would cover that enough. And then it looks like for the y values of goals, we have 0 to 4, so maybe 5 or 6 up would be plenty for that. So then what you do is you start plotting these out. So I go to the point 8.2, so over 8 up 2, put a dot. 4.1 over 4 up 1. 6.1 go over 6 up 1. 6.2 go over 6 again, but this time go up 2, put a dot. 8.4 go over 8 and up 4. 6.1. Now notice I've already put a dot on 6.1, so I'll skip over that. 7.3 go over 7 up 3. 5.1 go over 5 up 1. 9.2 over 9 up 2. 3.1 over 3 up 1. 6.3 go over 6 up 3. 2.0, that would be on that axis. 7.0 would be on the axis again. Another 2.0, so I already have a point there. 8.1, so over 8 up 1, and 3.0. Now, if I was trying to determine a relationship here, notice as the number of shots increase, on average, the number of goals also increased. Obviously that wasn't 100% completely true, but the trend is more shots you make, the more goals you're going to make. And so we would say that's a positive relationship. As you look at a graph like this, if it looks like the points are going up as you move to the right, then we say that's a positive relationship. Let's look at this problem. The following table shows the tread depth in millimeters of a tire and the number of miles in thousands that have been driven. We're going to graph these. So again, you want to look at your values here. It looks like my x values, my miles driven, start around 20 and go up to about 45. So maybe I don't want to graph values much lower than 20 here, because they're not really, there's no data there. That'd just be an empty part of the graph. For my y values though, I go from 1 to 5.5. So maybe again I'll go like 1 to 6. Notice this little jagged part there. What that indicates is part of the graph is missing. Instead of starting at 0 and 5, 10, 15, and then 20, I just said let's cut all that out of the graph and we'll just begin at 20 here. So then I'm going to start plotting my data. 25, 4.8. Again, I'm just kind of estimating. It's a little closer to 5 than it is to 4. 35 and 3.5, about halfway in between 3 and 4. 40, 2.1, again lower, closer to 2 than it is to 3. 20 and 5.5, about halfway to 6. And then 45 and 1.0. Now notice what's happening here is as we move to the right, my data points look like they're going down. In the other example, the data points looked like they were kind of going up, trending up. These are trending down. So we would say this isn't a positive relationship, it's a negative relationship. The more miles you drive, the less depth you have on your tread. You're wearing off the tire the more you drive. Something that wouldn't have any kind of relationship would either just be totally scattered around, no trend going up or down, or maybe there's a trend but it's going just like on a horizontal line, just flat. And in that case, that would be no relationship either. One of the values isn't changing while the other one is. Alright, so that's scatter plots and the Cartesian coordinate system.